All right, theoretically, I'm live. Hey, everybody, welcome to another Open Space, my Monday evening, just totally formless chat where you ask me a bunch of questions about space and astronomy, and you decide what it is that we're going to be talking about. Not a lot of info to catch you up on. We did another virtual star party on Saturday night, and it was problematic, as all virtual star parties are. I mean, each one is just a miracle of technology that we're even able to make the thing happen at all. Huge props to Nancy Graziano, as always, for working so hard to try to wrangle all of the cats. And it's like four-dimensional cats, because each person with a telescope may or may not have good weather conditions, may or may not have their gear working properly. And then we've got the moon that comes in. But anyway, we got a chance to see a bunch of cool stuff: North American Nebula, Mars, Saturn, and the Veil Nebula, and a bunch of other stuff as well. So it was fun. And clearly we need more astronomers, ideally in other time zones. So, but anyway, it was fun, and hopefully we'll try again on Saturday. We're going to go an hour earlier, though. So before we were doing it at 8 p.m. Pacific time. Now, thanks to daylight savings time, we get to move down to 7 p.m. Daylight savings time. No, now we're in standard time, not savings time. We all got an extra hour. I hope you all used your hour well. I didn't. I slept in and then walked around and changed all the clocks in my house. And yeah, hour used up. Oh well, we'll try again next year. As always, go ahead and put in any questions that you have. I want to remind you, of course, that if you put out a question and we don't get a chance to get to it during this hour, because I pretty much only get through about 20 questions during the hour, go ahead and just post it into the comments of the video, and then I gather those up for the weekly question show. We have a weekly question show that's done, ready to go. We found one error in it, so we had to re-render it. And so I was hoping to have it out today, but now it looks like we'll have it out first thing tomorrow morning. So we talk about the dark forest theory of the Fermi paradox. All right, let's get into this week's question. The first question comes from Corey S. Here's a question for you. I've seen some sources reporting on SOFIA's water discovery saying a soda can in a cubic meter, while others say it's a football field of area. Which is it? Of course, this is the announcement from NASA, the one that I went on the rant last week about how I don't like embargoed stories, about the discovery of water in the sunlit parts of the moon and the amount of water that's available in the regolith. And the press release that I had seen from NASA is that first one, that it was a 12-ounce water bottle of water in a cubic meter of soil. And that doesn't sound like a lot, but it's 1/100th the amount of a liquid that's in, say, the soil of the Sahara Desert. So it's still, it sounds like a lot, but it's actually not very much compared to other places on Earth. But still, if you're looking at spending tens of thousands of dollars per kilogram to bring water, actually more than that, $50,000 per kilogram to bring water from Earth, it makes sense to figure out some kind of system to be able to gather your water locally on the moon. And of course, the other thing is that we still don't know where water on Earth came from. Did it come from comets? Was it just available in the solar nebula as the planets were forming? We don't really know. And so it's going to be places like the moon, which are like a record of the history of interactions between the inner solar system and the environment. And so you can dig up the moon, the lunar regolith, and learn what the early solar system was like. Same thing as Mercury. You could go to Mercury and you could get just this geological record of what the solar system was doing in the early phases of its formation. And that's why, I mean, not just water for astronauts to drink. The reason you want to find this water is it helps us understand what happened in the early solar system. Because here on Earth, all the water is all mixed up. So, all right. Terry McHugh, which gas giant should we send a mission to next for my 12-year-old daughter? Hello, Terry's 12-year-old daughter. We have sent pretty good missions to Galileo. There's a spacecraft we sent pretty good missions to Jupiter. There's a spacecraft at Jupiter right now, which is Juno. There's another mission going to Jupiter's moon Europa in the next couple of months, the Europa Clipper. There's a European mission, which is also going to be doing this. So Jupiter's pretty well covered. Of course, we have the Galileo spacecraft. We have the Voyagers, the Pioneers. We've seen quite a bit of Jupiter. I mean, I'll take as many missions as possible, but we have. Saturn has been really well explored by Cassini for a decade. We only lost Cassini fairly recently, but it was there studying, orbiting around Saturn, going past its moons, really giving us a better sense. But the places that we haven't gone and we haven't seen much are the ice giants, Uranus and Neptune. They were only seen once by Voyager 2 when it flew past them. It went past Uranus in 1986 and it went past Neptune in 1989. And it was just a flyby, just a single flyby. And yet each one of these ice giants is fascinating on their own. Neptune has some of the fastest winds in the solar system. It has a moon called Triton, which has geysers like Europa and Enceladus. In fact, they were one of the first places that it's thought that these were discovered. It orbits backwards from the rest of the moons going around Neptune. Uranus has some amazing places as well. Both Uranus and Neptune have rings, which are very different from the rings around Saturn. So both Uranus and Neptune are really exciting targets that we should definitely be sending spacecraft to. At this point, there's no concrete plans to send any missions to Uranus or Neptune, but NASA has proposed a couple of missions, one called Trident, which of course, Trident, Neptune, so would go out and do a flyby of Neptune, but like a better flyby, and other longer flagship missions like a version of Cassini, but for Uranus or Neptune, have been proposed as well. But right now, there are no concrete plans to go back to those planets at all. Sierra Vortec, is SLS already obsolete and a waste of money? I get this question all the time. I guess we've had this question. I've been getting this question since SLS was first proposed. In fact, SLS is really just a new version of NASA's Constellation program, which was, I think, originally proposed by George W. Bush back in 2004. And so the original idea was that you would have two rockets. You'd have the Ares 1, which would carry the crew, and then you'd have the Ares 5, which would be this really big rocket, like the SLS. And then they would both launch. The crew would transfer to the cargo. Like once it was all in orbit, they would transfer over, and then they would go off to do whatever mission they were going to do, go back to the moon. And George W. Bush said that they were going to be going back to the moon. And then it changed a bit during Obama, and it changed over to the Space Launch System. And the whole program exists as a way to continue having all of the people who are working on the space shuttle. The space shuttle wrapped up in 2011, and you had tens of thousands of workers in every congressional district across the United States who had really good jobs, and the politicians were very concerned to make sure that these people kept doing their work. And so you got this transition as the space shuttle wound down. The Space Launch System, which is essentially the space shuttle, but just in a bit of a different configuration. It's still got that core hydrogen, oxygen fuel tank. It's got the solid rocket boosters on the side, but it's in a bit of a safer configuration. Instead of having the orbiter, the space shuttle orbiter, bolted onto the side, you've got more of a traditional heavy lift capsule on the top. And of course, that gives you the ability to abort and do other things like, it's a safer ride to space than the space shuttle. And of course, we saw with the space shuttle, we lost 2 orbiters over the course of that mission. So the purpose of the Space Launch System is to provide a follow-on heavy lift capability to the space shuttle, that it's safer. And of course, here we are in 2020. It still hasn't flown, even though it should have flown. It's gone over budget, like they do. And if it had been developed 10 years ago, the Space Launch System would have been a perfect follow-on to the space shuttle. It would have made a ton of sense. But here we are in 2020, and SpaceX came out of nowhere and developed just an entirely new category of rocket, the whole reusable rocket category, which nobody has been able to really catch up with them yet. Although obviously Blue Origin and other companies are working on their versions of it. And so where we stand right now, the Space Launch System is the most developed heavy lift vehicle on the planet. Nothing can compare to the capability of the Space Launch System. It can launch just a phenomenal amount of mass into low Earth orbit and to do some of the really deep space missions that NASA is planning. The Falcon Heavy gets you most of the way there. The Blue Origin, the Blue Origin New Glenn will get you most of the way there when it launches. But still, neither of those take you all the way to the capability of the Space Launch System. But they do it for a fraction of the budget. And so you're left in this situation where there is no heavy lift vehicle yet. Obviously, there's Starship. There's the Vulcan, whatever United Launch Alliance is planning. There's the Ariane 6, which is what Europe is planning. There's whatever the Chinese are up to. We're going to see it still hasn't shaken out. And what happens next will just depend on, like, if Starship flies successfully and is able to return from orbit and is able to demonstrate that it's fully reusable, top to bottom, both halves, then not only does it mean that the Space Launch System is irrelevant, but literally every other rocket system on Earth, apart from, like even Electron, it will probably even make more sense to launch stuff on a on a Starship than on an Electron rocket. Like, there's just, to not have to throw away any part of your rocket is such a deep paradigm change. But where we stand today in 2020, November the 2nd, Starship doesn't fly yet. Space Launch System isn't done yet. Blue Origin New Glenn hasn't done its single test flight yet. SpaceX is turning away from Falcon Heavy. Everything is still a chaotic mess. And until Starship demonstrates that it can fly, you would have to be a crazy person to shut down your program waiting for that rocket to be delivered. I'm sure that there's lots of people at NASA who are just hungrily waiting for any chance to launch on a Starship. It'll save them so much money. They cannot wait. And at the same time, Congress of the United States, it is the law that they have to build the Space Launch System because they're keeping all of these people employed. They're continuing U.S. Ability to launch heavier and heavier payloads. So we're in this very weird time, and we're going to have to wait to see how it plays out. If New Glenn launches and works well, then SLS is less required. You could pretty much do the entire return to the moon mission using Falcon Heavies and New Glenns. If Starship works, then everything changes. But where we stand today, Space Launch System still makes sense in that it is the heaviest lift vehicle that is under development on planet Earth, using a very traditional rocket system. So, would I personally cancel Space Launch System? Yes. If I was in charge of the budget, I would say, we can't do that anymore. And I would reallocate that budget to other things. But there's a tremendous political cost to do that. And as a Canadian, all we're concerned about is making sure that things have robotic arms on them. So that's where we're at right now. we'll see. I mean, next year it's going to get weird. The moment, literally, the moment a Starship returns from orbit, lands safely, makes it through the atmosphere, then that's the day that everything changes. Apologies, I'm looking at the questions. All right, use Nord. When will it be possible to make money from going into space? And why aren't rockets being sponsored? It makes money to go into space right now. When you look at SpaceX with the Falcons, United Launch Alliance, Electron, they're all businesses and they all make a profit from launching satellites and various things into space. Now, we don't see other things being launched into space because there's no business to be made for doing them. And you're going to need the costs of rockets to come down significantly that will enable that next revolution in space economy. Suddenly, different things will, like orbital refueling. Like at a certain point, launch costs will come down and it makes more sense to just launch a rocket filled with fuel and then you reload rockets while you're up there. And then prices come down and then maybe space tourism suddenly becomes a lot more economic. And who knows, maybe in the far future, prices will come down so far that, that it makes sense to mine stuff from space or do manufacturing in space or things like that. I'm not entirely sure that'll ever happen, but yeah, and so just what kinds of business activities will be made in space just depend on the launch costs getting off of Earth. And right now we're at it's still, the best price you can get is about $3,000 a kilogram to send something into space. Just pick up something that weighs a kilogram and ask yourself, would I be willing to spend $3,000 to have this be in space? And of course you can't buy it by the kilogram. You got to buy it by the metric ton. So, all right. No. Okay, Neil Yu's asking if Neil Yu's asking, Fraser, have you seen the video for Roscosmos swing wing boosters that glide back to runways? No. That sounds awesome. Please let me, can you put a link to that? That sounds great. I haven't even heard this yet. Grant W asks, are the Voyager spacecraft on a trajectory to a specific destination? No, the Voyagers are not going on any specific destination at this point. The job of the Voyagers was to follow the slingshots around Jupiter and Saturn, and then of course for Voyager 2 it followed on doing a slingshot around Uranus and Neptune, getting faster and faster. Once that was done, both of those spacecraft are just left on their trajectories, just moving out into space. And whatever was the final, they did their science and now they're swung out into space. They're not going towards anything. And even if they could go to the nearest star, for example, it would take them about 50,000 years. And the reality is that the Voyagers are dying. They are probably within 10 years or so of running so low on power from their reactors on board that they're going to have to just shut off their communications array and go silent. And so it is amazing that we are here 1970s, right? We're 30, 40 years after the Voyagers launched. And they're still operating. They're still doing science as they're out in the outer solar system. We just got a press release that came out today that thanks to Voyager data and now New Horizons data, it looks like there's a lot more hydrogen in the interstellar space than anybody thought. About 50% more hydrogen just in gas, just out in between the gaps between stars. Now, we don't know whether that's just our local bubble. There's this thing called the local fluff, the local bubble, that we are surrounded, that the solar system is passing through the hydrogen left over from some star forming region. Or maybe interstellar space itself has more hydrogen. But still, the fact that we're getting this data back from the Voyagers is amazing. But the reality is we're just like, within a few years, we will get the news that the Voyagers have run out of power and they've shut down their communications arrays, and that's the last that we're going to hear from them. Like what happened with Spirit and Opportunity and the Pioneers, and it'll happen in New Horizons too. So nothing that we do is interstellar. It's all interplanetary. Visto Tutti, could an asteroid be safely deorbited down to Earth for mining, not mass extinction? Yeah, I mean, an asteroid could be brought down for mass extinction. Could it be brought down for mining? I can't think of a way that you could bring that much mass through the Earth's atmosphere at the kind of velocity. Like you're at orbital velocity. I mean, think about what happens when a capsule enters the Earth's atmosphere. It's going around the Earth. It's going 28,000 kilometers per hour. It then descends through the atmosphere, slows itself down through the atmosphere, and then lands. And it sheds off all of that velocity. And it does it releasing an enormous amount of heat. And so if you had a asteroid going 28,000 kilometers per hour, which is like, imagine you had a nice safe orbit around the Earth and you tried to bring it down, it would probably fragment and it would cause a nuclear weapons amount of damage as it airbursted above some sorry site. Now, that said, I mean, some of the most productive metal mines here on Earth, like in Sudbury, and there's some places in South Africa and things like that, are old meteorite impacts. There's a chunk of nickel and iron embedded in the ground in Canada that we mine. And it's an amazing thought to think that this, like, it must have caused just untold damage to planet Earth, and yet now if you want a really convenient form of metal, it's right there in the ground for you. So I can't think of a way that you could, without just producing an enormous, requiring an enormous amount of energy, be able to bring an asteroid back down. But there's a couple of ideas, and I haven't looked into this too deeply, but in theory, I've heard you could take like a whole bunch of metal, mine it off an asteroid, spin it out into like a big fluff, like steel wool, but like really lightweight, and then you could drop it through the atmosphere, and it would shed the velocity away without burning up and land safely. So there might be a way that you could drop blocks of harvested metal off of your asteroid, but gravity wells are for suckers. Like, just keep the stuff in space out in space. There's so much need for it. We have mountains of metal here on Earth. It will always be more economical to harvest the metal here on Earth than to try and harvest it from space. So RCB asks, assuming cost isn't a factor, what is the largest rocket payload that can be launched from Earth? How does that compare to what can be launched now? I don't actually know the answer to that question, but I'm saying this because I want to remind myself to dig into it. So I will look into it after this video. For anything that I didn't really know the answer to very well, I do a little research after the live QAs just so that get it into my head for next time. But I do know that Elon Musk said that the current iteration of Starship is the smallest possible version that will perform this role of a fully reusable two-stage spacecraft. And so in theory, you could move to an 18-meter fairing. You could essentially double the width of the fairing of Starship and make an even more economical version of Starship. So the version that we see today that's 9 meters across will eventually probably double and still be even more economical. And I'm not sure at what point you are just reaching the limits of physics, of like how hot can the rockets, before you damage the actual rocket, what are the forces that are involved? I don't really know what the limits are, but it's a great question. Jason Collins asks, who would win in a war, Mars or Earth, and why? I mean, like a land war? Um, I would I would think Earth would win in a land war against Martians because they would be weak and feeble, um, which is but and then a space war. I mean, Earth has more resources than Mars, so it just depends on whether or not the Martians have access to asteroids and things like that. But you should definitely check out the TV show The Expanse. It's absolutely fantastic, and they have increasing tensions between Earth and Mars, and eventually they do go into a bit of a war. And it's pretty cool how it's tackled in the show, and it's very scientific. I was quite happy with how it was dealt with in The Expanse. So I don't have an answer, but definitely check out The Expanse as a sort of future version of hostilities between Earth and Mars. And of course, if we ever do get Starlink, we have to recognize the sovereignty of Mars. So, so that's the thing. All right. A.B. Scott and Flower. Fraser, do you ever plan to visit Boca Chica, Texas? I would love to see Boca Chica. Now, of course, right now the border between Canada and the United States is closed as we are dealing with the pandemic. So assuming the pandemic is over, yeah, that's on my bucket list. I will absolutely be going down. I'll talk to Tim. We'll do a road trip and go and check out the Starship. I mean, I love that. I mean, I've seen one rocket launch, and it was an Atlas carrying, or was it a Delta? An Atlas? And I think it was an Atlas carrying OSIRIS-REx. And it was a great experience. But people say that watching these heavy lift vehicles, the Saturn V, the space shuttle, is a whole other level of just visceral experience of watching a rocket launch. So, and I'm sure Starship will be next level. And I cannot wait to get a chance to see that. So, as soon as I'm allowed to re-enter the United States, I cannot wait to come down and watch rockets launch from Boca Chica. And hopefully it'll be more farther along. And of course, not just Boca Chica, but also they're building the same kind of facility at Cape Canaveral as well. And that might be the better place to do it. Cape Canaveral has other rockets launching as well. Lots of Falcons, lots of, hopefully then the New Glenn will be launching. So yeah, I can't wait to go places and do things with people. Come on, coronavirus. We've had enough of you. Oh, I just lost monetization on this video, but that's okay because I don't monetize any of the live streams. And why don't I monetize the live streams? That's because of the patrons. Thanks, patrons. No one has to see any ads on any of my live videos. All right. Cirilio says, have you seen the TV series The Orville? Do you like it? Yeah, I love The Orville. The Orville is like my second favorite Star Trek TV show. If you haven't watched it yet, it's terrific. Does a really good job of being a sequel to The Next Generation. And if you're like, oh, it looks kind of cheesy and Seth MacFarlane and the science is nonsense, I mean, those things are all true, but it has a charm to it that we really enjoyed, I gotta say. So yeah, big thumbs up from me for The Orville. We were watching Discovery as well, and it's kind of hit or miss. It just kind of takes itself too seriously. Lower Decks was terrific. I really enjoyed Lower Decks. It was nice to see a bit more of that comedy. It's funny. And we're watching the new season of The Mandalorian, which was, I don't know. I didn't like The Mandalorian last season, but I kind of feel like I have to watch it, and it was fine. It's okay. The show that I really liked was Queen's Gambit. So if you're looking for a show on Netflix that was super good, check out Queen's Gambit. I think I mentioned this last season, or last episode of the Question Show. But if you're looking for a show, definitely check that out. And then I watch a lot of stuff in Chinese. So I'm watching The King's Avatar right now, which is pretty good. All right. Lowell's DDZ. Hey, Fraser, what college did you go to and get your PhD from? So I don't have a PhD. I have a degree in computer science from North Island College, which is a university college here on Vancouver Island. Originally, I went to the University of British Columbia for engineering back in the 1989, 1990, and got 1 year into that, and then I left that to do a software startup with a friend of mine, and did that for a couple of years, and then I went and did another software startup, and then I left that to do Universe Today, and that was about 21 years ago. And then partway through, about 12 years ago or so, I went back to university and finished off my computer science degree. So my education in space and astronomy is entirely just through my work as being a journalist for 20 years. That and doing Astronomy Cast with Dr. Pamela Gay. I get to spend an hour every week grilling a PhD astronomer about whatever. So you know how like you ask me questions about space and astronomy? I ask Pamela all those questions about space and astronomy. And so if you have never heard it, I think you'll like Astronomy Cast. It's me having a conversation with an astronomer. Eric asks, hey Fraser, love your channel. What's your most crazy viewpoint about the universe that we live in? Can you give me more details on the question? Because I like the question, but I don't really understand it. So I would love to hear sort of more, like, do you give some aspects? Like crazy? What do you mean? What do I think is cool? There are a bunch of when I talk about like interesting facts, interesting ideas, I love to think about just to try to help people wrap their mind around the idea that the universe could very well be infinite, and that when you live in a place that has infinity, it is like, obviously our brains are not capable of really comprehending infinity, and yet we could very well live in it. And the consequences of being in an infinite universe are that everything that's possible could happen an infinite number of times, including this very conversation. So that we exist now. It seems like we missed the party, that we're here 13.5 billion years after the Big Bang. And yet, when you think about the total amount of time that will exist in the universe, we're actually really close to the beginning. That the future of the universe will have billions and trillions and quadrillions of years before the last black hole evaporates. And yet, here we are at the very beginning, which is very fortunate that we can perceive the observable universe, that we can perceive the beginning of the universe with the cosmic microwave background. So there's a lot of this kind of stuff that I really enjoy to think about. And yet each one of them you can only hold in your mind for a moment before the dark gibberings of Cthulhu sort of cross over from another dimension, and you have to, shake yourself out of it. So, but yeah, I love that we ponder eternity in this field, and it's one of my favorite things. And anything that starts to kind of get close to that. And then I also love that our generation, that we right now today, since the beginning of dawn of mankind, whatever, 1,000,000 years, only in the last few hundred years have we started to realize that we live on a planet that orbits around a star, and all the other stars probably have other planets. And only in the last 25 years have we been able to actually observe these planets. And really only in the last decade have we observed like a lot of those planets. And yet we're about to launch telescopes that will hopefully conclusively give us an answer about whether or not we're alone in the universe. Like that's such a haunting question. Are we alone? Is there anyone else out there? We don't know the answer to that. And in the future, generations from now, they'll know the answer to that with certainty. Like they'll go like, obviously, we're not alone in the universe. Everybody knows that. Or we're like, yeah, we still haven't found anybody, and we're 99.9% certain that we're alone in the universe. And we don't know the answer to that question yet. It is unknown, and we are watching it. We will get to be there when the answer to that question is either answered in the affirmative, life has been found, or that the chances of there being other life out there just gets more and more remote. And we're all living through this. It's the most important scientific question I think that humanity can ask, and we get to be a part of it. So, all right. Sam A says, hey man, I watched Interstellar again the other day, and the concept around relativity confuses me still. How can 1 hour on a planet be 7 years elsewhere? This is one of the ramifications of Einstein's theory of relativity, that there is no that everything is relative, that the speed of light is the one constant in the universe, and that when you travel quickly compared to some other person, or whether you stand in a very strong gravity well compared to some other person, you experience different amounts of time. And in fact, as you're standing here on the surface of the Earth, you're experiencing a different amount of time than the astronauts who are orbiting overhead, because they're in less of a gravity well. Now, they're also experiencing different amounts of time because they're orbiting around the Earth at 28,000 kilometers per hour. But all things, if you could stand on the surface of the Earth and have someone standing on the surface of Mars, your clocks would run at different speeds because of the strength of the gravity well that you exist in. And that is just one of the, I'm not equipped to go into all the details of general relativity, but that is one of the implications of relativity, is that time is relative to the amount of gravity that you're experiencing and the velocity, the perceived velocity of other people out there. It's pretty crazy. Eric 1, hey Fraser, I took your advice and bought a pair of astro binoculars. Now I really want to see more and do some astrophotography, but I'm really stuck on what to get. Would you recommend a reflector or a refractor? I have a high-end digital camera, but I would want to get an actual astro camera. Great question. So I've got a refractor right there behind me. So you've got binoculars, you're having fun, you want to take it to the next level. So it all depends on what you want to see. Do you want to see the kind of wide field nebulae and galaxies and things like that? Then you probably want to go, or do you want to go for planetary stuff, which are very small but very bright, and that will define your setup. A telescope that I like is like an 8-inch reflector, like an 8-inch Celestron, Nexstar, something like that. They're, the short tube reflectors. They're like a nice, versatile telescope that'll let you view things like galaxies and nebulae, but also if you put the right eyepieces and stuff on it, you'll be able to do planetary stuff, see moon, Mars, things like that. You can attach your camera to the telescope and to be able to view it. So if you're willing to spend, like $1,000, get a good mount, maybe spend $2,000, that's a way to go. But that is that's going to be temporary, and then you're going to decide where you're going to want to go from there. Because if you want to do more deep space, deep sky stuff, then you're going to want a different setup than if you want to do more planetary stuff. And both are super fun and really rewarding hobbies. So you've just got to find out what you like. But I would get a more versatile reflector like a Celestron. And you want a good mount, because if you are going to try to do some astrophotography, and then see how you feel. And by that point, you'll know the limitations of the telescope, and you'll be able to decide if you want to go deeper. But there's a lot of people that do incredible work with telescope, with like an 8-inch Celestron, and never even want to move away from it because it's such a versatile telescope. So that would be my recommendation. But I would recommend that you call Oceanside Photo and Telescope. Free plug, there you go, OPT, and definitely talk to them and just let them know where you're at right now. You've been using binoculars, you've got a digital camera. What's their recommendation to go next, and see what they think. ABQ Halsey, can you recommend a good pair of hiking boots? So I guess if you don't know, I also do a ton of hiking. I wear running shoes. So I actually I don't wear hiking boots. I haven't worn hiking boots for 10 years. I don't like them at all. I wear running shoes. Running shoes, when you get them wet, when you cross rivers and stuff, they dry out really quickly. Uh, the trick is just don't wear a lot on your backpack. So at this point, my wife and I have got the weights on our backpacks down. You know, my base weight is about 12 pounds. Her base weight is about 7 pounds. And then we put food and stuff on top of that. So you don't have to carry a lot of weight on your back. And that means you don't have to wear really tough shoes. And then I do lots of really long walks and hikes on my running shoes. And then I just wear the same shoes when I do hiking in the backcountry. Yeah, I'll never go back to hiking boots. Ugh, no way. Um, Amy Scott and Flower, do you think that Elon and Trump have made a deal to have Starship on the moon, on or Mars by 2024? I don't know whether there's been a deal made. Elon Musk is attempting to get Starship flying as quickly as humanly possible. I think right now, like gave a presentation at the Mars Society a couple of weeks ago, and the time scale that he said was we should see SN8 launch probably in the next couple of weeks. So probably before the end of November, we should see the 15-kilometer hop. We should probably see an orbital flight sometime in 2021, and he expects that 2022 is a little too early to try to launch to Mars, but maybe, and it'll probably be more likely to try and launch to Mars by 2024 to send the first spacecraft. And once Starship flies, then if you can refuel Starship in orbit, then you can do a moon mission. You just fly to the moon, land, fly off again, come back to Earth. It's amazing. And so the thing that needs to be figured out is the refueling of starships in space. And this is a big challenge. NASA recently announced a partnership with SpaceX. They're essentially giving SpaceX all of their technology for transferring cryogenic fuels in space. They're giving them gear, and they're teaching them how all of the engineering that they've done so that starships can refuel each other while they're in space. And this is a huge, if once that happens, then that's what it's going to take to be able to launch a mission, like a heavy mission to Mars. That's what it's going to take to launch a heavy mission to the moon. So the chain of events is going to be Starship's got to be able to survive going orbital and coming back to Earth. And then they've got to be able to master transfer of cryogenic propellants in orbit. Once they can do those two things, then the entire solar system is their oyster. He used nerd. What is Elon's real end game? Well, I'm extrapolating what Elon's real end game is, but I get the sense that Elon has the same existential opinion that I do, which I mentioned several weeks ago, but I'm not going to go too deeply into it. But the gist is we have no evidence that there are any other civilizations in the universe, that right now we know there's life on Earth, but we don't know of life anywhere else. And we do know that the clock is running down, that there are various existential issues that face humanity that will set us back. And not only that, but we've used up a lot of the readily accessible resources on planet Earth. So if we wipe ourselves out and the octopuses try to rise up, or the dolphins or the chimpanzees, we've used all the coal, and we've used all the oil, and we've used all the readily available minerals, and we're not going to go through the Carboniferous era of Earth again. The sun is heating up, and in 500 million to a billion years, it's going to wipe out all life on Earth. It's going to boil the oceans. You don't have to wait for the sun to turn into a red giant. And so we have no evidence that there is life in the universe. And life makes the universe better. And I'm not talking about like humanity, like just anything, like nudibranches and ferrets and oak trees. Like the universe is made better by having life in it. And through our cleverness, we've gotten ourselves to a point where it can be we can wipe out ourselves, and we can also set back Earth's ability to try to get life out into the universe. And so we need to hurry and take responsibility for that. Until the aliens contact us and say, don't worry about it, we've got it under control, there's a galactic federation, we'll send you the designs for the warp drive and you can join the federation. We kind of have to assume that the responsibility is on us and that nobody is going to come and fix it for us. And we are making our planet worse. So all in the sort of all at the same time. So I think Elon's long game is to give humanity a firm foundation in space that will then, and same thing with Jeff Bezos, to allow us to be a more hardened, versatile, resilient species and have a better chance at being able to go beyond Earth and to try to help keep life in the universe beyond what happens. Again, wouldn't it be terrible if we found planet after planet after planet, just beautiful blue worlds with no life on them across this entire Milky Way, and we were the ones who could have fixed it. We could have helped life get out there into the universe, and we didn't, because we wanted to drive our cars and eat fast food. So I think that's Elon's goal. And that's, it's kind of my goal too. But sort of, I had this realization like 20 years ago. I'm just like, man, like we're going to wreck it. And we don't know if there's any other life out there. And that would be sad. So that's, I think, I've never talked to him personally, so I don't know if that's the plan, but we've had enough interactions on Twitter and stuff that I sense that that's the plan anyway. Curious Borg says, but if we need the AI to get there, aren't we already hosed? Yeah, artificial intelligence as an existential is just one of the existential threats that we face, that we will develop artificial intelligence, that we will deal with pandemics, that we will cause nuclear war, that we will outstrip the capability of our planet to support ourselves. There's innumerable ways that we can fail in our ability to become more resilient as a species. And yeah. Mr. Man, could Starlink someday provide internet that is unfiltered and unrestricted by governments or corporations? I don't know exactly how Starlink is going to work, but from what we understand right now, it is already unfiltered. That the way Starlink satellites work, and if I'm getting this wrong, somebody can tell me, but essentially they are like the old networks that used to run in your house that would broadcast network traffic to every computer in the entire house, and then your computer would reject any traffic that wasn't meant for it and filter out everything that wasn't supposed to come to you. And so right now, all networking is done through routing. So, if you want to send a message to somebody, the message has to go to a router, and the router says, oh, this belongs over there, and it sends it to this packet, sends the packets to that router, and that router says, I know the final destination. And so at any point along that chain, anyone can look at your data, as long as it's not encrypted, and be able to see what you're talking about. The routers. But with Starlink, each Starlink is essentially just going to be rebroadcasting all of the data that's coming to it. And then your receiver is going to be dumping any of the data that isn't for you, and it's going to be using in decryption to be able for you only to be able to decrypt the data that's meant for you. And that pretty much is unfiltered and unrestricted. Starlink will work in China. Starlink will work in Russia, because, maybe the Starlinks will be turned off as they fly over Russia or China, and that'll be part of the requirement from those countries. Otherwise, they're going to shoot them down. But I think that we're already at this point. Now, to own a receiver, you can't, for you to own a receiver in China, you're going to have to be able to buy one. It's going to have to be legal by the government, and I'm sure they'll never let them do it. Like China's going to roll their own worldwide constellation of internet satellites, guaranteed. So, but yeah, so it looks like it's already at that, which is that Starlink is already, as one of its other benefits, is that there's kind of no way to filter it or monitor it unless you can get the decryption keys to be able to see the data. But that's, as I understand it today. It could be that it changes, but that's, it's pretty neat. We've actually got an article that's coming on Universe Today in probably the next week or so, all about how Starlink packet switching is going to work, because there could be some routing, like where you're on one side of the earth and you're trying to send data to the other side of the earth, and so you're transmitting up, and then your data will transmit across the Starlink network and then make its way back down. And so you can imagine the Starlinks routing the data across themselves to get to the other place and then to transmit it down. But and so we're doing an article about that right now, about how the data works. So my knowledge of it right now is a little rusty, but hopefully we'll be able to give you more information. If you haven't already, subscribe to my weekly email newsletter, and when that article goes live, we will be able to post it. universetoday.com/newsletter. Jason Collins, I'm a huge fan. What are your top 3 craziest theories for dark matter? No science is acceptable. Oh, it's that last sentence. No science is acceptable. Man. Oh, I should have like a good answer for that. I'll think about that after the fact. Some really good, off the cuff, ridiculous explanations for what dark matter is. But if anyone has some crazy ideas for dark matter, please put them into the comments. That's awesome. All right. Kara Isabel, if we're moving super fast, the planets and everything in the universe, how come stuff isn't just flying everywhere or flying away? So, I mean, I'm going to try to sort of interpret this question. Like, you're sitting on the Earth right now, and at the equator, the Earth is rotating at 1,000 kilometers per hour. Every hour that goes by, you have moved 1,000 kilometers. The Earth is orbiting the sun at 30 kilometers per second. In other words, every second that goes by, you're 30 kilometers farther than where you were. The Earth, the solar system is orbiting around the center of the Milky Way at about 220 kilometers per second. So again, 220 kilometers. The Milky Way is expanding away from other galaxies, moving away from other galaxies at 70-ish kilometers per megaparsec. So there's all kinds of motion. And so the question is like, why don't you feel it? And the answer is a couple of them. One is gravity, that you don't experience, that if you actually like got on a scale, if the Earth was rotating, if the Earth wasn't rotating, you would lose like a tiny little bit of weight because you're essentially being pulled away from the center of the Earth because of the Earth's rotation. But it's very slight. When you're thinking about the Earth going around the sun, same thing. You're just experiencing this momentum. You have already been accelerated to 30 kilometers per second, and you are going around the sun. And so, we don't feel changes in velocity. It's the same thing. Like when you are in an airplane and the airplane is flying at 1,000 kilometers an hour, you don't feel it because you only experience accelerations. You don't experience velocity. And so all of these speeds that we're moving around the sun, around the Earth, around the Milky Way, there's not a change in the velocity, and so you just don't experience it. Let's see. I'm going to go back. A lot of great questions. Apologies. I just saw good question here, and I lost it. I'm so sorry. It's gone. No. There was something about hooking up telescopes to computers. Oh, here we go. User asks, will telescopes hooked up to a PC be a lot cheaper in the near future? Yeah, I think so. There's a couple of new telescopes. There's Unistellar and there's I forget the name of the other one, Stellina. And essentially they're computer powered astrophotography telescopes. They're very easy to use. They take pretty great pictures, and they are just so easy to use. You just use them with a smartphone. You just go like, I want to see a picture of the Orion Nebula, and then it just turns to the Orion Nebula, and you get a picture of the Orion Nebula. And they're doing really well. They're very expensive right now. They're like $2,000 or $3,000. Stellina is making a cheaper version of their telescope that should be like more like $1,000. And so I think we're going to see the prices of these things just come down and down and down, like we see with everything, with drones, with cell phones, all of this. Although weirdly, cell phones just keep getting more expensive. But anyway, yeah, so I can imagine that we're going to see cheaper versions of these as the technology gets developed. Like this is clearly what the telescope industry was needing, was computers to manage all of the nonsense of making a telescope work. Because if anybody has ever bought a telescope, especially one with some automation in it, you know how awful it is to try to make the thing go. Like literally just point at a star and stay pointed at a star. It is half an hour of you going, hold on a second. Oh, wait, I've got to polar align it. It's the worst. And so these companies are figuring out ways to be able to make this an easier, more effortless process. I mean, you use the Stellina, and yeah, it's like $3,500. It's a very expensive telescope, but it works so nicely. You just put the thing down, you press a button, beep boop, and now you're taking pictures of space. And anyone who's done any astrophotography, anybody's ever used a telescope, just gets how dramatically different this experience is. And so, but the actual technology of finding its location on Earth, it's just a compass, GPS, figuring out what time it is. It's a clock. Doing plate solving to figure out what it's looking at in space, that's not very complicated. So I think we're going to see a revolution of these come up. Whether you're going to be able to connect to them with a PC, who knows? I mean, I think we're going to have just cheaper, better telescopes that are easier to use. 10 years from now, telescopes are going to be really cheap, really easy to use, really powerful. It's going to be a different world. All right, let's see. I've got maybe time for one more quick question. Whoa. All right. Well, actually, that was okay. So, Jiro the Hero, if the minimum mass to make Jupiter a star was added to it, would it totally disrupt the solar system? Yeah. So right now, Jupiter is not a star, and it's made of exactly the same stuff as stars, hydrogen and helium. But if you were to add 77 more Jupiters to Jupiter, then you would have the minimum amount, the absolute bare minimum to have a red dwarf star. And it would ignite in fusion in its core, and we would have 2 suns in the solar system. But of course, to add 77 times the mass of Jupiter is not an insignificant amount of mass, and it would completely disrupt the solar system. So please don't do it. I'm begging you. Don't increase Jupiter's mass by 78 times. All right, we've reached the end of our hour. So thank you, everybody. If I didn't get a chance to answer your question and you really still want me to answer it, go ahead and put it in the comments. I sort of see the comments afterwards and gather up a bunch of those questions for the question shows. So if you still are, if I didn't get a chance to get to your question, that's the second way. We're going to be releasing a question show probably later on tonight. the question show 130, and we talk about the dark forest theory as an explanation for the Fermi paradox. So stick around for that. Thank you, everybody, for watching. I have a really good time with these. Thank you, of course, Nancy Graziano and the rest of the moderators for helping manage all of the comments and put the questions in a place where I can get them really easily. I really appreciate that. It makes my life so much easier. And we've got some interviews coming up, not this week, although maybe we won't put one at the last minute, but I got a great interview, Peter Voigt, next week, quantum physicist, and then Chris Carr from Weekly Space Hangout the week after that. So lots of good interviews coming up. All right. Thanks, everybody. I hope you all stay safe, take care, and we'll see all of you next time.